Hello everyone. Today we are going to study about the nature of radiation. Light is an electromagnetic radiation, and as well as light shows the dual nature. According to law of refraction and reflection of light have a particle nature. But the other phenomena like diffraction and interference, if you try to explain by accepting the wave nature of radiation, then only you can explain this one. But by accepting the particle nature, we can't. So we can say that the light have a dual nature of radiation. The first nature, that is a wave nature of radiation. The wave nature of radiation was proposed by Huygens, and particle nature of radiation was proposed by Max Planck. Let's write down. Nature of radiation. Light is the electromagnetic radiation and it shows dual nature, that is wave nature and particle nature. Wave nature of radiation was proposed by Huygens and particle nature was proposed by Max Planck. How can we say that the light have a dual nature? By accepting particle nature of radiation, we are able to explain reflection and refraction phenomena, but we are not able to explain diffraction and interference phenomena of light. This phenomena can be explained by accepting wave nature of radiation. Albert Einstein observed that when radiation having sufficient energy strike on the metal plate, the electrons of the metal plate gets excited and released in form of radiation. This effect is known as photoelectric effect. The smallest part of the radiation is known as photon. To calculate the energy of photon, the equation was given by Max Planck, that is E is equal to h mu. Let's define the each term. E, energy of photon, h, Planck constant, the value is 6.626 into 10 raised to minus 34 joule into second. Mu is the frequency of radiation, but the frequency is equal to c upon lambda, where the c is velocity of light in vacuum, that is 3 into 10 raised to 8 meter per second. Substitute the value of frequency, that is mu equal to c upon lambda, in this equation. Therefore E is equal to hc upon lambda. This one is the equation to calculate the energy of the photon. When we are going to use this equation to calculate the energy of photon, the unit of that energy is joule per photon. One more definition: the energy of 1 mole photon is known as 1 Einstein value. 1 mole, that is Avogadro's number. 1 mole equal to 6.022 into 10 raised to 23. Multiply this equation with Avogadro's number, then the equation we have Ne is equal to nhc upon lambda. How can we identify in a numerical that given value of energy is a 1 Einstein value or just the energy of photon? Then on basis of the unit you can identify the given value is 1 Einstein value or the energy of a single photon. Unit of the 1 Einstein value is joule per mole. The wave nature of radiation, that was proposed by Huygens, but the explanation of the wave nature of radiation, that was given by Maxwell, and that is known as Maxwell electromagnetic radiation. According to him, any charged particles is in motion with acceleration then it always produces the electrical field and magnetic field around it. This electrical field and magnetic fields are perpendicular to each other as well as perpendicular to the direction of the propagation of wave. Therefore, the wave is known as electromagnetic waves or electromagnetic radiation. This thing we will see in a next topic, that is electromagnetic radiation. Okay, write down please. Next topic that we have, wave nature of electromagnetic radiation. As we discussed in the previous topic, any charged particle in a motion, it's always produce the electrical field and magnetic field. This electrical field and magnetic field are perpendicular to each other, and these fields are also perpendicular in the direction of the propagation of waves. This observation was given by Maxwell in 1850. As we discussed in previous lecture, James Maxwell in 1870 observed that when electrically charged particles are accelerated, then this particle produces the electrical field and magnetic field around them. This electrical field and magnetic fields are perpendicular to each other, as well as they are perpendicular to the direction of propagation of light. These waves are known as electromagnetic waves or electromagnetic radiation. James Maxwell in 1870 observed that when electrically charged particles moves under acceleration, it produces electrical field and magnetic field and transmitted in form of wave. Therefore, these waves are known as electromagnetic waves or electromagnetic radiation. You can see this thing in a diagram that is on your screen. You can see that the rays is in a propagation direction, and according to that the electrical field and magnetic fields are perpendicular to each other. Not even that, these electrical fields are perpendicular in a direction of the propagation also. That is known as properties of the electromagnetic radiation. Here I am trying to showing the direction of electrical field and magnetic field. These are the three axes XYZ, that means a three-dimensional system. This one is the direction of propagation of light, that means the transmission of the light occurs in this direction. Then the electric field produced, that is supposed to be like this, and magnetic field, that is perpendicular to this. So the property of the electromagnetic radiation that we have, the electrical field and magnetic field are perpendicular to each other as well as perpendicular to the direction of propagation. Second, electromagnetic radiation, they does not require medium to propagate. Means the sound waves without a medium, that is here is a air. We cannot hear the voice of any person. In a universe, that is a vacuum, the sound wave cannot propagate in a vacuum, while the electromagnetic radiation can propagate with a speed of light, that is 3 × 10⁸ meter per second. That means electromagnetic radiation does not require medium to propagate. Third, in vacuum, all the electromagnetic waves have same speed, that is 3 × 10⁸ meter per second. That is the velocity of the light in a vacuum. Fourth, electromagnetic radiation are differentiated by its wavelength or by frequency. The relation between them is mu equal to C upon lambda, where the mu is the frequency of radiation, C velocity of light, lambda is a wavelength. You can see in a figure that is the different type of electromagnetic radiation, that are radio waves, microwaves, X-rays, UV rays, visible light, infrared rays, right? I am showing these things in a diagram that have frequency as well as wavelength. You can observe the frequency of the gamma rays, that is 10 raised to 21. The frequencies of the X-rays is 10 raised to 19. The ultraviolet rays 10 raised to 17. The visible rays, that is 10 raised to 15. Infrared 10 raised to 13. Microwaves 10 raised to 11. And radio waves 10 raised to 7. Frequency is measured in a unit of hertz, that is second inverse. In a visible ray, that has a collection of the 7 lights, that is Vigbor, we know that, right? Their wavelengths, that is also given in a diagram, you can see.